Hello everyone, it's me, Christian, and I'm here just to record this little walkthrough of an extension or an update to the really neat game that Ning made a few weeks back. If you're familiar with that workshop, Ning led the way through making a cookie clicker clone that really showcases the basic uses of React for making a single page website, and so or a single page web app. And the purpose of this video is to just show you how you can integrate this front end technology with some really useful back-end server tools. So what we have here is an update to the cookie clicker game that has a very poorly formatted high score list. And so the idea is we can play the cookie clicker game. We can have some fun, racking up really high scores. Let's see, I'm going to try to get up to, I'll try to get maybe 81 cookies is pretty good. And I'll say, I want to submit my score. This was a good game. So I can say, I am Christian for demo. And what I can do is I can submit. And look, my score is stored here. And not only that, I can leave this web page. And I can return, and this state was stored not on my local instance here, but on an external server. And in fact, that you can see the external server here right now. It's running in it's a Node.js server, and so I'm using the Express library for hosting. And what we can see here is most of this code is mostly the same. I just added this right here, which does all of the back-end fun behavior. And so what I'm going to do is I'm just going to walk everyone through how we can make a high score list to this game. And so prerequisites, things that I expect the viewer to already have set up, is as a Node environment. I believe this was set up in the course Lapilli, and installing Node or a Node package manager. I use NVM, Node version manager. It's helpful for if you need to switch to a different version of Node for one reason or another. And then some sort of text editing environment. I'm going to use VS Code because it has a lot of really neat debugging capabilities, and that helps a lot when developing for both React front-end projects and Node.js back-end projects. So without further ado, I am going to clear out everything that I have here, and I'm going to switch back to the version of the cookie game that was finished during the last workshop. So just so that way, if you want to start, if you want to follow along, you can. I'm probably going to have a link in the description of the repository that you'd want to clone. So what I'm going to do is, in fact, I'm going to make a new, just clone it again. I'm going to rename my cookie repository to cookie finished, and then I'm going to clone Ning's repository. And so we're cloning. We have all our fun things going on. I'm going to exit this, and what else? I will go forward. And I suppose, let's see, we can start. So this is what everyone should see. This is just, the last version of the code that we have. And remember when we were running our Create React App projects, we ran it through a special tool. There are different ways of doing it. We can have npm run, let's see, I believe it was serve. Actually, npm run. Let me find the. Let's see, run start was what it was called. Let's see. Let me remember the exact name of the command. Oh right, okay. So this is a good test of myself. Is that this repository that we have here doesn't include all of our node modules by default, which makes sense. It would be a waste of us to be downloading and uploading those to GitHub. So before we do anything, we should run npm install npm install save. This installs all of the different node modules that are needed specifically for the front end React project. So let's install these. Wait for these to install, and let's try this again. Npm run start. So we're starting the development server, and let's see what happens. So look, this is the familiar version, or the version of Cookie Clicker that we're all familiar with, that we worked on previously. Unfortunately, if we close this and then go back, it doesn't save our status. And for most web apps, you want to store something on a server so that way when you come back, it has some useful information that you left behind there. And there are different ways of doing this, but one common procedure that's very useful and it's very easy to get started with is called Express. Now, Express is a library that does cool backend server tasks, mainly serving HTTP requests. So if we broke down our web app project into two chunks, here's maybe this down here. Let's see, up here is our front end. This is our Cookie Clicker game. We'd want to have some other software that's always running that could store some useful state for us. So this is where our backend comes into play. And I'm going to use Express here. So what do you want to store? What do you want to store, right? Let's say we just want to store high scores. We want to store, the high scores of people who have done well in this game. That way, people can go back and be proud of their accomplishments. And what we want to do is we want to transfer this information in the form of web requests. We might be familiar with these from class, but you have different commands, standards of requests. You have the ones that we're going to be working with right now are get and post. So if we want to pull some information, suppose we want to pull the current list of high scores, maybe we might want to set up a get request to say, okay, I want to get some high scores from this backend. And this is all like really high level. I'm being intentionally vague here, just because you could implement these requests in almost any programming language. You can write a backend in C++ if you wanted to. If you could write a backend in Python, that's not too uncommon. But what we're doing here is we just want to see what are the basic tasks that we want to do, and how are we going to accomplish this with this library that we're using, which is going to be Express. And I'll show everyone how we do that. So basically, we want to be able to post high scores to this backend, store it in some way. In this case, it'll be a file, and then get that information back later when we want to. So how do we do that? And so first of all, I'm going to close this demo, and I am going to clear out some of this other stuff. And let's say there are some things that we need to install first, some libraries that we need to use. So what I mentioned I was using Express, and Express is a library that handles these requests for you, so you don't have to worry about the nitty-gritty under the hood. So what I'm going to do is I'm going to run npm install save express. This is the library that we use. Let's see. and we'll wait for that to install. Okay, we have Express there, and what I'm going to do is I'm going to make the very most basic web server program possible with Express, and we're going to demo it to see how it works. And so I'm going to make a new file. I'm going to be running this in VS Code, like I said, since that way we can visualize things a bit more easily. And I am going to make a new file. I'm going to call it server.js. That's just what I'm calling it. And I'm going to be using Express. So const express equals require express. Boom, right? So then this is our library. You know, we can refer to it later. And with Express, we have like an object called our app, or I mean, we can call it our app, but basically this is where we configure. Basically, what we want to do is we want to bind functions to different web requests. If someone sends a particular GET request, we want to bind a function to say, oh yeah, I'm going to call this function every time you send this request. So what we do here is we say const app equals express. This just sets up our web application, and I am going to make the most basic web page front end that we can think of. So what I'm going to do is I'm just going to say app.get / and then I'm going to have my second parameter to this function is it's going to be another function. In this case, I'm going to use an arrow function, and you'll see what's going on here. But by default, we pass our request and our response to this function, and we'll see what happens here. And what we want to do is we want to have a basic text page rendered when we go to this web page, when we go to this server. So what we'll do is we'll just say res.send hello world caps. I keep thinking I'm in Vim. And then what we can use is at the very end we'd want to say app.listen. Let's store the exact port we want to host on. I think I use the same port that the create React app used, which is const port equals 3000. So we're just hosting on this port. I mean, this is arbitrary. You can host on whatever port you want, but if you want to host on like the port 80, you might have to you have some weird permissions issues pop up because it's often a restricted port. And so I'll just say I want to listen to this, these endpoints on port 3000 or a port. And then once I connect, I want to. This is a callback function, right? If you remember, callback functions are called after this task happens. That's how we can do asynchronous programming here. So what I'm going to do is I'll just say console.log web app listening at HTTP localhost, and then I'll template this, but we have our port. And for template strings, if we remember, this is a cool feature in JavaScript. We don't have to have any weird concatenation. We can just put in this template here, and it will build a new string that has our port dynamically updated. Or I mean, it'll have our port, whatever we set to here will be rendered there. And I'm going to make a new terminal so we can just run everything here in this window. I don't know why I ran clear there. Let me make sure I'm saving the server. And what I want to do is I'll create a new launch.json file. It's really nice. I could run this in the terminal if I wanted to, but it's nice to use the watchers and debuggers that are available in VS Code. So let's just have this here using Node.js. Just no fancy configuration. And look, we have web app listening at localhost 3000. Let's see what happens if we click that. Look at that. We have our very own very basic web server. This is we've made a backend program. So to recap, what did we do? This is the meat of our program so far. We have an endpoint here that responds to a GET request, and what it does is it just renders this string. And so this is pretty cool. It's not too exciting though, because it just does the same thing every time. What we want to do is we want to use this backend to store some useful information, some useful state for our project. And so what we can do is we can show how we can build some dynamic content here. So what if I made a variable, or you know what, I have another example here. Right now we have this on basically the root of our website, but we can set this to listen to any arbitrary endpoint, any arbitrary URL, I suppose, and take some action specific to that endpoint. So what we could do is I could do something like this. Noodle, and I'll say let's say every time you navigate to localhost/noodle, we will have a little counter, and I'm going to have a variable here. I'll just use let noodle count equals 0. And what if we do this? Every time we go to this website, or this particular page on the website, I want to increment my noodle count. I'll say noodle count ++, and then I can say I'll again use the templated string. We'll say there are blank noodle count noodles. And I know this is going to be an error when there's going to be 1, and it's not going to be grammatically correct, but this is going to be sufficient for our example. And so what do we want to happen here? We want this to store some state between accesses to this particular page. In this case, that noodle count. So what are we going to do? Let's restart our web app. Every time that we make a change, we're going to have to restart it. We can go here, and let's go to noodle. Look, there are 1 noodles, and if we refresh, 2, 3, 4, 5. How about that? Is that really nice? So that's just an example of showing some dynamic content, some dynamic information that we can send and we can receive, and we can use it to modify our display on our front end later down the line. So this is all fine and dandy. We're able to download information, but what if we wanted to post information? Because that's really useful for a lot of web pages, right? We want to be able to post something. So how do we do that? Well, remember that there's a specific idiom that we can use here in hypertext transfer protocol, which is the post request. So what if we bound some functions to this post request to maybe update this noodle count dynamically? And let's get rid of this and say, what if we want to define how many noodles are in our noodle variable from our web app, and then retrieve that later? So here's what I'm saying. What if we say app.post, not port, post, and let's say set noodles, or set noodle count, and then we call this function res. Notice what we did with this arrow function right here. This first parameter here is a reference to our request object. It contains information like who sent the request. You can even find out which browser they're sent from. Eventually, we want to pass some information aside from the request itself. Our request body is going to be stored here, and then this response is just going to be what we write our data to when we're ready to send a response. So what I want to do is I want to do something along the lines of this. I want to say, oh, okay, let's suppose maybe we send a JSON object to our noodle count, and what if we did something like this? What if we could send little message bodies that were formatted something like this? Let example message. What if we did just a simple JSON key value pair, where we could say new noodle count, and have this just be some integer. And so we want to send, blocks of information like this. And the best way to prototype that, because eventually we want to send this from our web app, but to start, I like to use a program called Postman. It's a very nice program. You have to sign up and give your data to them to use it, but it's free, and that's free software comes at a cost. But it's a nice piece of software. It's really useful for prototyping. Highly recommend it. We'll wait for this to load. There are a few more modules that we're going to have to install to make this work properly. Basically, we want to send. What do we want to do? We want to send some formatted data from a client, from our front end to our back end, in a format that our back end can understand. It's common to send data in JSON or XML. I like JSON just because it translates really nicely to it's JavaScript online notation. It translates really nicely to to Node.js JavaScript code. But in order to do that, we need to install a parser. We need to install a module that parses this JSON for us. We don't want to do that manually. So what we need to do is we need to install a module, Npm Install. It's called Body Parser. And this is going to do all the heavy work of parsing JSON for us. So that's all cool. Now what we can do is up here we can import that. We can say const body parser equals require. Let's call this body parser. All right. And then what we want to do is we want to specifically use the JSON parser. I believe they also have an XML parser, but let's initialize our JSON parser objects. We can say const JSON parser equals body parser dot JSON. Right? I don't know why this is body parser deprecated. Well, there used to be a built-in parser in Express, and they started using body parser. Now it appears that that's deprecated. I don't want to be recommending, students to use deprecated software, but this works for now. If there's a better solution, then I'm sure we'll find that out in the near future. But basically, what we want to do is we want to parse our data that's being sent to our post requests. So what if we do this? We can say we have this. There's a concept of what we call middleware in Express, and this is kind of jumping in. It's just some more advanced concepts, more advanced topics, but that's what body parser is. It's middleware. And so what is middleware? Well, basically, we could directly get information raw from our web page, or no, from our client. We can send a request, and we could try to take some action on that. But oftentimes, it's in a format that's not friendly to us. Like in this case, it's sending these raw bytes, but we don't know that they're JSON objects yet. In some cases, you want to double check a particular, state before you take some action on a request. Like, what if your page is restricted via password? Before you do anything, you want to obviously check if the user is logged in. And so, what you can do actually is you can use this structured middleware, and the idea is in between this function that you call at the very end, you can add another function. That's what basically this JSON parser is. It's a handler. It's an event handler. JSON parser. Oops. JSON parser. And what happens is that every time that we get our noodle count our set noodle count rather. We get this post request. We run it through this JSON parser, and then after that, the result of that gets pushed to this new this request response function, this callback function, I guess. And why do we do these things this way? Because it's really modular. Suppose I don't like this JSON parser, I want to use my own. You know, you can make some function and you can pass it as a parameter here. But basically, that's just a high-level overview of what this middleware is. There's middleware, and then you can even say something like this. If you want to use this JSON parser on all the requests, we could say something like app.use JSON parser, and this just will basically call that function, call that middleware every single time that any endpoint is retrieved via a get or post or any web request. But I don't think we would really need to use the JSON parser on the get requests. So that's fine. So what do we have here? We have our JSON parser. Now what we expect is we want to be able to get some information that looks like this example message. So let's just start by printing out the message before we do anything fancy. So what if we say console.log, and we can say body.example message. How about that? And then we can create a new request. So I'm going to make a new request here, new basic request. I'm just going to call this let's see, demo for 35L. I just put in the hacks, and then what we can do is we want to post something to localhost 3000, and then this is called set noodle count. And then let's just say we have our body. It's going to be in JSON format, and we have a little message object, message example. Let's not call this example message, let's call this message. We have a message object, and within this message object we want to have our new noodle count. And one thing I often forget is that although JSON is very close to like the normal object notation that we have in JavaScript, you have to remember that you have to use, for any string, any identifier here, we use quotation marks. That's what they're called. Let's say I want to set my new noodle count to 12. And this looks like everything's formatted pretty nicely. So I guess I can just try this out. One last thing I'm going to do though is every request that's being sent, every web request that's being sent under normal circumstances is going to try to listen for a response. And so we're just going to give it a response. res.send we got your message. So what are we saying? Our response. Let's send to our response object, we got your message. Pretty simple, pretty straightforward. How about that? So what if I restart our server? Let's make sure I don't have any weird bugs, and let's send. Let's see. Uh-oh, error. Body is not defined. Oh, yep, that should be request.body. So a cool thing, which something that works nicely here with Express, a standard behavior, is that if there's an error, then it'll send that error in your response, so you can see it pretty quickly here. Let's restart now that we've fixed that typo. Let's send. Look, we got your message. How about that? Let's try something now. Let's try updating our noodle count. console.log. Actually, let's say noodle count. Noodle count equals rec.body.message. That's what we call this new noodle count, I think, in our body. New noodle count. New noodle count. So now we are updating the state on our server every single time. So what we do, rec.res.send, we got your message. All right. So what we have to do is just go and let's also say we got your message. Noodle count is noodle count is noodle count. So let's try this. Send. Look, noodle count is 12. If we set this to 99, what happens? Noodle count is 99. So you know it's storing this information, but is it? Well, what if we just go to noodle and see if it stored this state? Oh, right. This is a GET request. Noodle is a GET request. Look, there are 99 noodles. And if I want to set this back to 2, and I send a post to, this is called set noodle count. Boom, noodle count is 2, and then we can go back to our GET request, check it out. Look, it stores our state here. So this is a big breakthrough for us, right? We can use this for a lot of really useful things. So we're going to start expanding this by setting up a high score system, something a little more advanced. And look, we have our printouts here. But how do we want to set up our high scores? Well, we could use a database, and that's what we should use in a a more structured, full-fledged program. But the thing is, installing databases is different based off of your different platforms, and you could spend a lot of time talking about configuration. I don't want to spend too much time talking about that. So I'm going to say we're going to set up the most simple, hacky version of a database, which is just a file that we store our. Remember, we want to make a high score list. We store our high score list in. So what we're going to do is basically retrieve high scores, store it in a file, and then serve those high scores when we feel the need to. So the first thing we need to do is we need to have some. We need to be able to handle files. That's the file system library node module. So we could say npm install -s fs. Fs is for file system tools. And then we want to npm install what do we call this? Path, because this lets us handle and manipulate paths. What do we do? Oh, I misspelled npm. So go through this. It's installing. Now I am going to make a new file. I'll call it my my high score list. This is going to be our very advanced database. It's just going to be a JSON file. High score list.json. And what's it going to be? Well, I want my high scores to just be an array, really, of objects. And that array, we'd probably want that to be in order from highest to lowest. But let's just have an example of what we want it to look like. So say if we have Eggert. Let's say that Eggert has a very high score because he's really good at cookie clicker. And then we also have Ning. Ning designed the game. He's pretty good at it, and he might have 800. And then I'll just put myself here. I have a high score of 12. And this should be a good start. So basically, what do you have here? This is an array. It's an array of 3 objects. We have, Eggert's object, Ning's object, and my own, and they're all in fairly the same format. And so this is the format that we want to use. We have a name, and we have a score. You know, actually, I should separate these. I think this would be a little easier to handle if we have something more structured like this. We have name, Eggert, score 9999, and then once again we have our name, and we'll see why this is a bit more useful down the line, but name, Ning, and then Ning's score is going to be 800. Let's make sure of a comma, not a period, but a comma. And then once again, name Christian with a score of 12. So this should be pretty good. We have name scores, that's all good. And we just have 3 people in our high score list. And we want to be able to, let's start by getting a high score. Just something basic. One thing that you really might want to do is, this is a common design practice, is not to put too much business logic directly within these HTTP requests, because you might want to change something about your middleware, you might want to change the specific format of the message body, and then you're going to have to start messing with more code than you need to. So it's always good practice to have some sort of layer of separation between, this low-level behavior that's not going to change much based off of like your front-end structure. This is more of a middle-end structure, really, and then your actual requests. And here's an example. Let's make a function specifically to get a list of high scores. So let's say function get high scores, and we're going to do something like this. Let high score list equal fs dot. We can read files synchronously or asynchronously. It's probably a good idea to do this asynchronously. So how about we do this? I'm going to do something a little different. I'll say I'm going to return a promise, and this is this is a form of asynchronous programming. Resolve reject. Then what we want to do is we want to do this. Let's make this an asynchronous function. Async function get high score list. I want to return this promise, and let's say let high score list equals. I need a double dictionary. Yeah, this will be good. Let's say fs file system dot read file read file. What we want to do is let's have a path, high score path, and then we're reading in the UTF-8 format, and then once this is done, let's see, this is done, it's gonna make a callback function. So our last parameter will be this function, which will have our high score list. Man, this is in raw string, so let's say a high score string, right? And then what we want to do after all this happens is we can say let parsed. We want to parse this because it's in a plain old string. We want to parse into a JSON object, or more a JavaScript object. We'd say let parsed equal JSON.parse, and let's call this high score string. Looks pretty good. Let's print out our parsed information here, just because why not? Console.log parsed. And then what we want to do is we want to resolve this promise. So that way, it's sort of like a callback. It's saying that, you know, this asynchronous task is done. Let's resolve it. Resolve parsed. Alright, let's try that out. So our high score path, we need to write it out. And let's just call it, let's see, const high score path equals / dot, and what do we call this? High score list.json. We just put it all in this top level directory. Okay, this is looking pretty good. I haven't had anything yell at me for problems. And what I'm going to do is I'm going to see if I can just call get high scores. I don't think this is going to work. Yep, no. So instead, what I'll just do is I'll just call this function immediately. Get high scores. And let's restart. Undefined is not a promise. Get high scores. Return promise, resolve, reject. What's happening here? Let me set a breakpoint to see what exactly is going on. If I've messed up my formatting or anything. Type error, undefined is not a promise. I wonder what's going on here. Let's see. Do I need a keyword? Maybe I do. I probably do. So let's run again. FS is not defined. Let's say FS. Read file of undefined. I don't know why the linter wanted to auto fill some of these for me, because these are not the format in which I wanted them, but it's okay. Let me get rid of this breakpoint. I think we've resolved our issue. Oh, look, we have null. That's better than nothing. Let's see if we can read our file. Let's try this again. Let's run. Let's launch our program. So we didn't get anything. fs.readFile, highscorelist.json, highscorelist.json. It should be working. Highscorelist.json, highscorestring. Maybe the first is error. I have to remember the exact callback. Yeah, the first one is an exception. The second parameter is a string. That was my mistake. And now we have our high score list that's parsed. That was a little embarrassing at first, but look, how about that? We made a function to asynchronously get our information from a file, which is good. And the reason why we have this async function is the following. We can say get high scores, and then after that we can say .then once I do get those high scores, I want to take some action on this, and this will be my high score list. It's my parameter for this, I guess, like a callback function. I can say console.log my high scores are, and then this is going to be really big, so I'm just going to put in another line, console.log high score list. How about that? Alright, so what's going on here? Boom, my high scores are this list. Alright, great. So we're able to get high scores, but now we want to store high scores. How are we going to do that? Let's do the following. Let's make another function that can save high scores for us. So again, I'm going to make another asynchronous function because this is going to take some, it's going to do something that might take some time. We don't want to stop everything else. So what if we did the following? We can say async function save high scores equals, let's see, high score object. It's just to save a single high score object. And then what do we do here? So we want to get our current high scores, and hey, look, for us, we already made a really nice program or a function that gets these for us. So what I want to do is I'll say let current high scores equals await get high scores, right? And then what I want to do is I want to push my new high score. I'll call this new high score. I want to push my new high score to my list of current ones. So what I can do is I could say current high scores dot push new high score. This just appends it. But what? Another thing that I want to do is I want to sort these. And how do we do that? There's a built-in function for sorting arrays, but I'm not sure if our built-in function knows how to handle our these aren't just like strings or numbers that we're sorting. We have to specifically tell it to sort based off of this score field. So what we can do is we can actually make a new sorting function. I'm going to call this compare high scores, and this will be first object, second object, and this is what we're going to do. I'll shorten these: first object, second object. And then what we can do is we can say if my first object dot score is less than my second object dot score, I'm going to say return 1. If my first object dot score is equal to my second object dot score, I'll return 0. And then if my first object dot score is greater than my second object dot score, I'll just return -1. So this is basically, it's 3 possible outputs. That's what we kind of need for a sorting function, and JavaScript handles the rest. So all we need to do right here is we can just say current high scores dot sort, and then we use our compare high scores function. And boom, bada bing, bada boom, we now are sorting our high scores. And then what we want to do is we want to write our file. So we can say fs.write file, and we'll say our high score path, because obviously if we wanted to change that, we don't want to change it everywhere, so we set up a constant. And then what we can do is we want to turn our high score object back into a JSON string. So what we can do is we can just say json.stringify current high scores. We want this in UTF-8 encoding. And then I'll split this up since it's starting to get kind of long. Our encoding is UTF-8, and then we have our callback. And this is probably just going to give us some, let's see, what is our callback? I think that the documentation will tell us. It's probably just going to give us whether or not we have an error. What was the error? Not that. Yeah, it's the only parameter that's passed. So we can say something like if error reject there was an error plus error, right? Otherwise, and then in return, because we don't want to resolve. Otherwise, we can just say resolve success. And I'll probably stop being lazy and I'll put this in a proper block of its own. And I'm gonna clean all this formatting. Alright, so what do we have here? To save our high scores, we take this asynchronous function. Oh yes, we need to put this in a promise. We need to return a promise. That's how we can do some asynchronous programming here. So what we can do is we can say return new promise, resolve, reject, and these resolve, these rejects, these are like two different potential callback functions. One that we call on failure, one that we call on success. Resolve is the one that's success, reject is the one that's failure. And that looks like it should be good. I haven't checked at all to see if the formatting's right. Maybe I could do that. But let's just run this to see how it looks right now. So what if we do this? I want to get my high scores, and then what am I gonna do? I'll just say I want to save a high score. Actually, yeah, how about I do this? I can save high score, and then my object that I'm saving is just a new high score of myself. I'll say name is Christian 2 to distinguish from any other high scores I've already saved, and my score is going to be 35. Then I'm going to get my high scores. Then, and then after that, I can have my little function here. I'll say my high scores. My high score. This should be a sorted array of my high scores. And so what we have here is this fancy syntax that just basically puts this parameter into this. I might be completely butchering this and it might blow up in my face, which would be embarrassing to record, but it wouldn't be the first embarrassing thing I've recorded tonight. So what's going on here? Let's run. Oh, we have an error. What's up? Maybe I'm just being silly. My score list. Let's launch this program. We still have an error. Where is our... This is where the debugging comes nicely into play. Let's restart this. Looks like the error is happening before any of this is happening. What are our problems? Oh, I must be missing some syntax. Oh, of course. How about this? Look, we added our new high score and it's sorted with Eggert at the top, me somewhere near the middle, and Ning above me. So look, we have a new function that inserts a high score object. It uses some cool JavaScript features. It retrieves the high score and it saves it in this. Oops. It saves it in a file that we can retrieve later for useful purposes. Okay. So this is all cool. So now we need to start binding these to our server functions, our post, our get, what have you. So let's first set up an endpoint. Let's set up a get request that gives us our high scores when we need it. So let's do this. app.get high scores. app.get high scores. Then what we can do, request. You know, the nice thing about this format here is that if you wanted to get high scores, if you wanted to, you can put this little callback function, you can define it somewhere else, and you can even put it in a different file. I'm just going to show an example of defining it somewhere else. You can have our resolve, or no, our request and our response. So what are we doing? Yeah. So request or response, get high scores. And then what we can do is, all we need to do is we need to show our high scores when we get them. So let's say res.json, and this will be an async function because we're gonna do some asynchronous stuff here. Let's say res.json await, because this is remember this is an async function. This is get high scores. Get high scores. Let's see if this works. Oftentimes things don't work well on the very first try. So then what we do is on our high scores we can say get high scores. That's our handler here. Oops. Yeah. Get high scores. So it looks like it's gonna work. Nope. Response.json rec res. Interesting. Well, let's stop this. Am I doing something silly? app.get high scores. Get high scores. Oh, you know what? I already had a function called get high scores. Let's say high what do we say? Web high score handler. It's very verbose. Say web high score handler. Let's try that. Bada bing, bada boom. It didn't crash immediately. Now let's try to make a get request. High scores. And I'll get rid of this breakpoint here. And look at that, we have a list of our high scores that we can now retrieve remotely. And the cool thing is that we can do this. High scores. Look at that. So this is a big step. I'm going to pause this because I got a call.